is numerical based on electrostatics potential energy, right? My dear, in last class already, my dear, I taught you everyone concept on electrostatics potential energy. My dear, electrostatics potential energy defined for two things, two concepts. What is first beta interaction potential energy and second beta self energy. So I discussed, my dear, good evening. I discussed, my dear, basically concept on interaction potential energy for a pair of charged particle, right? So students, based on I can say previous concept, my dear, it's normal video, beta Suchit. My dear, it's normal video. Yes, beta. Okay. So now, Bachaji, what is the question, beta? It's a good question, my dear. Right. You can enjoy these questions, kids. So, students, question is that, student, there are, I can say, kind of a setup. You can take, my dear, and with the mass of particle. Charge, students, you can take here. This is 10 coulomb. Another beta particle mass. This is what, my dear? It's 2m. Separation beta between these two masses there initially. G, and you can take, my dear, this is a 15 coulomb. Beta initially, uh, no beta, it's not short. It's live class, my dear. Uh, can I check once? No, beta, it's live class. It's live class, my dear. Okay. So beta, this is the initial setup, my dear. Again, I'll repeat here. Mass beta 10 coulomb, mass to much 15 coulomb. Initially, are both are separated at a distance d. My dear, both system initially at rest. The student, both system initially at rest. This is beta. I can say first condition, my dear. Okay. Now, students, uh, beta after due to some chemical changes and all, I can see beta. I release the particle, both of this. My dear, I release this particle. You can tell beta, this is masses remains m. This is what, my kids, masses remains 2 m beta. I release both of this student. So you can see like charges here. Beta, this is remains as usual 10 coulomb. This is what, my dear, it's 15 coulomb, right? Okay. Now beta, I released here. Then what you can see, like charges repel each other. And this is what we do. So beta, for this condition here, you can take equilibrium condition becomes 2D. Means beta, after once you will release the setup, beta separation between the particle becomes 2D. My dear, for this condition, sir, we have to apply. Very good. God bless you, beta. God bless you, my dear Suchit. Beta, well done. Now, students, I can say for further dear, that is what. Beta, for this condition here, find find V1 and V2. My dear, find V1 and V2. Beta, very good questions here. Literally, beta, awesome questions. Now, beta, everyone be attentive here. Listen carefully, my kids. Now, students, I'm going to solve this question step by step. So now, this is students. I can say step one for these questions. So, beta, maybe I taught you. Beta, do you know song here for this kind of questions? I taught you, my dear. Do you know beta song for this kind of question, Bachaji? If we have only beta, my kids, if we have only conservative force, anyone from all of you here? Anyone from all of you? Sir, SR, okay, Hare Krishna, my kids. Hare Krishna. Okay, fine. Student step one here, beta, you can apply. Beta, in the questions, if we have only conservative force, my kids, in the questions, if we have only conservative force, then students, you can apply over there. That is what kinetic energy initial plus beta potential energy initial is equals to beta g kinetic energy final plus potential energy final. Right, beta? Okay. You can say a system initially trace beta. So what about kinetic energy initial here? Zero. What is the initial potential energy beta? Already I taught you everyone here. What is the potential energy pair of charge particle? K Q1 Q2 by R. So here bacha I can write this is what my dear K into 10 into beta G 15 K Q1 Q2 by and what's the subtraction initially dr which is equals to half mv1 square. Both are in motion, bacha. But you can take care plus or minus here, no need to worry because already it's a square. Half m beta g, you can say v1 square plus my kids half into 2m into v2 square. Now here we have to write final kinetic potential energy. So this is what again bacha k q1 q2 by r and r is what becomes 2d my kids. So you can say k into beta 10 into beta z 15 by beta what you can say 2d. Very good beta. Now what you can say beta solve your further student essentially you can write 15 times a 1 5 upon g which is equals to beta half m my dear v1 square plus beta z half 2m into v2 square plus beta z k into 250 by d. Now beta this two here, I'll keep this side entire beta. So what you can say bacha ji, this is what you can write 300k by d and this is what 150 by d bacha. So I'll take care this side 150k by d which is equals to beta simply here you can write mv1 whole square plus beta 2m into v2 square. Now with just solve further, you can write, so this is 150 by d, which is equals to mv1 square plus my dear 2m into v2 square. Now bit I can see we have a two variables which are how can we solve? In step two, my kids, I'm going to apply. Let us say equations number one. Up momentum conservation bacha. Here students, I'm applying linear LMC here. Linear momentum conservation, my kids. Change your life, sirs. It's a short format. Come live at Suchit beta, I'm not much right. So beta, I I'll see later with Suchit, right beta? I'll see my dear. Okay, so what is better linear momentum conservation principle? Acha? If we have F external acting on the system is equals to zero, then you can apply LMC. So here is what I'll write here P initial, which is equals to beta G P final. P initial students, which is equals to P final. What is the P initial, my kids? System remains zero, yeah. So you can write this is what zero is equals to beta g. What is final here? You can say bacha m into minus v1 plus beta. This is 2m into v2 here. Just beta equate these two with us. We can say v1 is equals to 2v2. Okay, Suchit beta, you already wrote here. I'm proud on you, my dear. Suchit beta, you already wrote beta. I can say, sir will get S. Yes, correct. Correct beta. V1 is equals to 2v2. Very good. Awesome, beta ji. Awesome, bacha ji. Now, beta, you can say, beta, for this condition, I'll beta use this here in equations number one. Beta, I'll use equations number two values in equations number one here. So in step three, beta, I'll just calculate further my kids. This is what 150 by d, which is equals to m beta. V1 square, yes, you can say 4v2 square plus 2m into v2 square beta plus 6 here. So you can say 150 by g is equals to 6m V2 square. You can see beta 25 times here. So beta I can write V2 is equals to what, my dear? 25 by m into d. Now here once you will get rid of V2 here, you will get finally with the byte, you can find your V1. So this is a good questions, my dear. Beta, God bless you, Sujit beta. Very happy to see, my dear. Okay. Now here, have a look beta ji next questions here. Have a look beta ji next questions here. Beta, if you join delay, my dear, anyone from all of you, then beta take a snapshot. Take a snapshot, my dear. Okay, fine. Now, students, I'm going to start here. I can say next numerical. This is what my kids, these kind of questions I did here in previous lecture, not in today lecture. Students, you know, this is basically we have an equilateral triangle, right, my dear? Okay, with our charges here also see every corner of an equilateral triangle. I'm placing charges remains same, my dear. You can take beta. This is what side becomes A. Bacha, in this question, find work done. What's the question, students? Write down with me, everyone. Find work done to bring these charges on an equilateral triangle. Equilateral triangle. If side becomes beta A by 2. Anyone from all of you, can you try this question? No, beta, in last questions, I did last question, Sushi. What question did with last class, my dear? There is what? An equilateral triangle, right? And side becomes two-way. Very good, Sushi, beta. I'm proud on you, my dear. Yes, beta, ji, right. I did this question in last class. But now, beta, I'm doing what I'm telling you, bacha. This is what? If side becomes A by 2, then you to find bacha. Then, beta, you need to find what is the work done. Beta, have look, bacha. I can see in solutions, my kids. Yes, Sushit, beta. You are, I can say, rock for the today class, bacha. Yes, beta. So now, students, I'll again here redraw the diagram. I don't know where one P, Q, R, S, T. Okay, okay, I'm waiting. I'm waiting, beta. I'm waiting, beta. I'll wait. Do my kids? Uh, P, Q, R, S, T, you got very much delayed. Suchit, I can say he is solving this is beta. I can say second questions. Why got delay all of you writing chat blocks? Okay, okay, Suchit, come beta. Come, my dear. I'll explain. Now, students, I can say this is what my kids, it's initial, bit I can say setup. This is Q, this is Q, this is Q. Beta side length is equals to A. In the question mentioned, students, if side length becomes A by 2, then here we have to find work done. Then beta, we have to find work done. I hope, my dear, all of you remember here, work done is equals to change in potential energy. My kids, you can write work done due to external agent is equals to change in potential energy. So you can write, my dear, work done due to external agent. Change here, you can see this is U final minus U initial. If you remember, beta, I can see all of you, those watching me, I taught in last class, beta, by short trick. This is Q, this is Q, this is Q. What is the potential energy for an equilateral triangle? Thrice of KQ square by A. I taught this thing last class. So initial beta, how much here? You can write with the party, sir. This much only. You initially you can write with a 3KQ square by A. What about U final beta? U final you can see remains 3KQ square, and this is what? Side becomes A by 2, my kids. So you can write U final is equals to 2 3s are 6. 6 times KQ square by A. 6 times by dear KQ square by A. So what is here? I can say work done due to external agent 3KQ square by A. So this is, my dear, I can say result of these questions. Yes, bacha. So, ready for next questions? Yes, 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 yes. Ready? No, again, I'll better give one more question, Sujit, better for your practice, right? Good question I'll give you. So that you can easily learn this kind of format, how to apply this kind of concept in the questions. Are you ready for next questions? Are you ready for next questions, my kids? Okay, okay, good, 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 good. Everyone here, show your beta. I can see enthusiasm like Sujit here. Sujit literally beta performing very much well. Okay, questions beta. Now down fast, everyone here with me. Find work done. Find work done due to external agent to shift a charge. Find work done due to external agent to a shift a charge. Figure show. Remaining beta, I'm showing everything beta in the diagram only. Right, my kids? Okay. What's the questions, students? You can have a look. Beta, this is, we have a Q charges. This is also, my dear, it's a Q charges. You can take beta, I can say L is a side of a, you can separate charge particle. Students, I can say we have a third charge particle on top. You can treat beta as an equilateral triangle. Yes, beta. Third charge particle here, I can say on top. Beta, we have to find work done due to external result to shift this Q charge to at midpoint of these charges. To shift which charge is this Q charge at midpoint of these charges. Right? So literally, beta, it's a very good question, students. Very good question, bacha. In fact, beta, you can beta find two things. One beta work done due to external agent, and second beta you need to find work done due to electrostatic force. Work done due to beta electrostatic force. Yes, beta. You need to find two things. Okay, okay. You can try beta. You can try. I'm finding it. I can see refill of this one. I don't know where it gone. Mm. Sujit, are you doing beta or I have to do? Tell me fast beta because I'm looking your response. You said na, I'll try. So I have stopped my dear. If you will say yes here, then I'll start to solve. Okay, okay, my dear. I'm waiting, my kids. Uh, oh, done, Sujit? Okay, I can say, sir, please allow me 60 seconds. Okay, you also wanted time. Okay, I can take. You can take your time, my dear. Okay. What is your answer, Vacha? Okay, fine. Okay, so now beta, I'm just solving it because I already got answer of these questions. Okay. Beta, first I'll find my gates. Work done due to external agent here. It's very easy for us. Students, I can say work done due to external agent, which is equals to beta change in potential energy. And what is my dear change in potential energy here? We can say U final minus U initial, right? So with the first, I'll write individually here. What is the U final, right? But sir, U initial no need to worry here. U initial beta remains constant here. 3 K Q square by beta G, what we can say earlier. Here beta I have taken here. This Q is equals to small q. That is the conditions, my dear. Okay. Uh, now bacha, you finally are BB to write. Bacha, if this particle will come over here, so what can we write? Bacha, you can say, sir, first you can write. Make it a one more diagram. How this is. Q, Q, and Q. So, but I know it's a interaction potential energy, my kids. So first, you can write here due to these two interaction, these two charge particle. I'm writing beta individually or U final. So this is KQ square by L plus interaction potential energy due to these two charge also. So this is what you can say KQ square by L by 2. L by 2 and entire beta G multiply by 2 because you wrote this expression for two charges. You wrote beta this expression for two charges. Okay, my dear. Very good. Oh, so see, beta, wait. I'm solving, my dear. I'll tell. So, work done beta due to external agent here, you can write 2 to the 4 here. 4KQ square by L plus beta KQ square by L minus here 3KQ square by L. So 4 minus 3 beta 1 here. So we can say work done due to external agent is equals to, my dear, 2KQ square by L. This is the answer beta for the question. What is the answer beta? Suchit, what is your answer? Your answer is not visible. Your answer is not visible, my kids. Okay. This is the answer beta for this question here. Because beta, this is U initial PQRST PQRST beta, this is, I can say, you final beta Z. Simply beta, I can feed over there, bacha. You will get answer, bacha. Work done due to external agent. Okay. Beta, we have to also find here. We should find work done due to electrostatic force. You know, beta, it's a conservative force here. I got that only, sir. Okay, very good, beta. Very good, Suchit, beta. Now, work done due to external agent with property, you can say minus times work done due to electrostatics, right? So you can write what's a work done due to external agent is equals to minus 2kq square by L. So beta, this is the answer here I can say for both of the questions, both part of these questions, right? Okay, okay, my dear. Now we are have a look next question, beta ji, for same pattern. Okay, those joined, I can say delay beta. You can go and watch lecture here. My dear, this questions here. What is question, kids? Listen to me carefully. Beta, this is charged particle. You can say beta ji Q1. This is fixed. Keep in your mind. This is fixed. Now, beta, I can say Q1, Q2, Q1, Q2. Beta, both are initially I can say finite separation, which is equals to R, which is equals to R, right? Now, students, Q2 are released. Q2, my kids, released, right? Now, which I can say this is what, which I can tell you, this is R1. Once Q2 has been released, my kids, Q2 finally, it can say comes, I can say at a distance of R2. But we have to find at this condition, find speed at R2, find students speed at R2. But a very good question here. Find speed beta z at R2. Okay. You want to try beta, Suchit, or I have to do? Okay, good. You can do beta. I'll wait. I'll wait my kids. Uh, I don't know what about PQRST. No one joined till now. Maybe all of them were doing masti. That is what I can say. That is for sure. Because till now no one joined, so I can say strongly all of them were doing masti, only eating and sleeping. That is the primary job for everyone. Yes, I can tell. No, I had one refill, but I don't know where it go. Okay. My dear kids, how and I can say what's your name and where from where are you watching Beta live session? Please write in session chat session here, chat book, comment box, live session here. I wanted to see from where are all of you because there are looking. I'm looking. There are five candidates. One is Suchit. Suchit is I can say regularly they are solving the questions. I wanted to know remaining. I can say fourth candidate. Okay, okay, beta. Now I'm doing my kids. Come. Bacha, you know, this question here. We wanted to find speed of particles. Okay, okay. So it's from Bangalore, Narayana. Okay, fine. Okay, come beta. I can see student applier in the solution part. My kids very simple beta. You can do my video. I said beta, if we have only conservative force, my kids, if we have only conservative force, if we have beta only conservative force, then beta I can sing a song here. This one beta, kinetic energy initial plus potential energy initial is equals to kinetic energy final plus potential energy final beta party. We can apply at this one. Right. What about the initial vector system at rest here? So we can say kinetic energy is equals to zero. What about potential energy here? As I said here, interaction potential energy for two charged particle. So this is you can write K Q1 Q2 by beta R1. What is the kinetic energy final here? Because this particle has charge Q and mass M. So this is what beta? Half mv square plus final potential energy, my kid. That is, you can say K Q1 Q2 by R2 beta. We are interested to find V bacha party. Beta take care. These entire terms beta I can say left side. So you can take beta K Q1 Q2 common, my dear, 1 upon R1 minus 1 upon R2, which is equals to my dear half mv square. You can take here, but I can say LCM. So this is K Q1 Q2 R2 minus R1 upon beta g R1 into R2, which is equals to half mv square beta. 2 beta g, just do your cross multiply twice K Q1 Q2 beta R2 minus R1 m times of beta g R1 into R2 to the power 1 by 2 is equals to V. So this is my kids. I can say answer for these questions. What about your answer? I can say oh, very good. God bless you, bacha. God bless you, bacha. Okay, I see here. I can say how many kids? No one wrote. Okay, Suchit wrote, sir, Bangalore, Narayana. I can say one more candidate wrote, I am from Bangalore, Sahakar. Okay, both of you from Bangalore only. I don't know from where are remaining three candidates they are watching. Till now, they didn't mention anything here. Okay. Fine, Vacha Party. Next question, sir. So this is the beta very common beta and very basic questions, right? You can beta do these pattern of questions here. Now, beta, I'm going to teach beta a new concept here. That is beta designed only for JEE Advanced. Beta, this is what known as my kids. This is known as closest distance approach. What my kids known as closest distance approach between charge particle. Beta, literally, it's a beta. I can say very good concept here. Yes, my kids, very good concept here. Everyone must know about. I can see these all concepts. So how can we solve here this pattern of all kinds of questions, right? So beta, we remember everyone here. We I can say stay tuned. Listen class carefully. Otherwise, it's very tough. But so what is the you can ask, sir? What is the closest distance approach? Yes, my dear. Closest distance approach. Beta, it's a very good point, Betsaji. But I think there are three cases which I'll teach you, case one, two, and three. my kids. But beta, I can say in J here. In J bacha, they means they use beta case one and two. I can say regularly they are using. Case three beta only for red ones. How bacha party you can learn here. Closest distance approach. Beta when two charged particle moving same polarity. What is students? When two charged particle moving with the same polarity. You can see, bacha, this is charged particle. I'm just taking here. You can see this is Cuban. When two charged particle moving with same polarity, right, are projected towards each other. When two charged particle moving with same polarity and projected towards each other. You can say, my dear, this is V1. You can say, beta, this is what V2. Beta, there are two charged particle here. Beta, both are what? Moving each other. Right, my kids? Okay. Along the same line of motion. Beta, there is conditions here. Along the same line of motion. Then due to their mutual repulsive force, student, then due to their mutual repulsive force, their speed decreases and they get closer to a minimum separation. Because due to repulsion, this speed got decreases and they will come close to each other. And beta, if they will come close to each other, my dear, so we can say those distance is what known as closest distance approach. Sir, I think I learned this in chemistry first year. Beta, na, that is different, Vacha party. Maybe just beta, maybe beta, you are familiar about this. I can say beta only words, not much concept. Beta, physics and chemistry both are my kids different concept, my dear. I hope you got it. My concern, what I want to tell you, right, Bacha? So this is beta. I can say closest distance approach. Again, I'm repeating. If we are projecting a two charged particle with same polarity, but its speed started decreasing, right? Beta, finally they get closer to a minimum separation. What dear? Finally, bacha party you can say Q1 and Q2 comes to what beta? Minimum separation. This is what, my dear, you can say minimum separation. Beta, this minimum separation between the particles when final speed becomes zero. Beta, when they achieve minimum speed, bacha party, because both are initially projected, finally both are at rest. Right. So this minimum distance is known as my kids closest distance approach. Closest distance approach, my dear. Okay. Beta, I can say there are three cases, bacha. Beta, we learn here, I can say closest distance approach. We will calculate to apply momentum conservation, energy conservation, and using concept of what? Interaction energy. To get beta result of my kids, what bacha? You can say for minimum distance, beta here I'll apply concept of interaction potential energy as well as my kids I'll apply beta that is what my kids basically you can say momentum conservation if required. Again beta I'll apply energy conservation to my kids, right? Okay, fine. Now students, this is I'm going to start beta case number one. Now, beta, I'm going to start case number one. What is case number one, students? Here, beta, I'll keep one charge, student. Here, I'll keep here one charge is basically kept fixed. One charge is kept fixed because they will not move. This is the condition here for this condition. Okay, sir, there it was closest distance approach. A proton can reach to nuclei since both are positively charged. That is in a bit of a chemistry, but here you can see which this is up to advanced here. And they asked, my dear, many times case 1 2 for means advanced bacha party that is case 1 year. One more candidate, I can say cyber. Okay, solid to you, sir, beta. Me here. Why beta? Why solid here? Why you are beta saluting me? What's the special? What you felt at this point live class? Tell me any special thing there, beta. Okay. So now, students, I'll say my kids. This is there. Plus Cuban, and my dear, this is what remains fixed. My dear, this is remains fixed. Okay. Fine. Now, students, I'm going to project here. This is Q2 charge particle, and mass of this particle beta I'm considering M. My kids here I'm considering bacha party M. Now, beta I'm going to here because already it's conditions. One charge is kept fixed. Now, students, I'm projecting here Q2 towards Q1. With speed, you can take beta V naught. Right, beta? You can say, bacha, initially both of the particle at large separation. Initially, bacha, you can say both particle at what? Large separation. You can say, bacha, but this is what? Large separation, my kids. Okay, fine. You know, beta, I said here, because both what? Like charges, so repulsion is there. Both like charges, my kids, so we can say repulsion is there, my warrior, right? So what you can say, students, so this charge particle, because this charge particle has initial kinetic energy initially, so they will what move towards q1, but due to repulsion they will not stick, they will not go more closer. Finally, beta, due to repulsion, because this particle only has a velocity, this is remains at rest. So you can say, bacha, both of the particle at a any finite separation, Q2 also will at rest. Students, if Q2 and Q1 what remains at rest initially. If Q2 velocity becomes zero, you know, bacha, this separation is known as, my dear, R minimum. Or you can say, beta, this is what? Closest distance approach. Because the closest distance approach. Closest distance approach. Kinetic energy will convert S. You right, beta Sujit. You right, beta Sujit. Yeah. Perfect. Very good, bacha. So here, students, I'm going to apply, bacha. I can say energy conservation, my kids. Here, students, I'm going to apply, or I can say energy conservation, my kids. Applying energy conservation. Students applying energy conservation. You know, beta, entire year we have only conservative force. I thought, bacha, what is the things that you can apply? You can say, bacha, kinetic energy initial plus student potential energy initial is equals to kinetic energy final plus beta potential energy final. Simple, my dear. Okay, what is initial kinetic energy, bacha part? You can write here half mv square, half m, bacha ji, half m V square. Okay. What about initial potential energy? No. You know, beta, interaction potential energy, what we are learning and what we learned only for interaction here, that is for finite distance. But initially they are at large separation, so bacha, there is no potential energy initial, bacha. Very good, bacha ji. Now, my kids, come here. You can say, bacha, what about kinetic energy final? Zero na bacha, because Q2 also zero here. So we can say this is what zero. What about potential energy funnel, my kids? Tell me, sir, this is na. You can say, yes, sir, we can write here interaction potential energy because they are at what? Minimum separation, my kids. You can say K Q1 Q2 by beta G R minimum. Yeah, we wish to find this party only. Do your cross multiply and divide. So our minimum beta you can get finally, my kids. Our minimum beta you can get, my kids. That is twice times Q1, Q1 beta G, Q2 by M V square. So this is what beta I can say. Case 1, we got result as a what, my dear? Closest distance approach. Suchit wrote something. V naught square, sir. V naught square. You correct, beta. Okay, I wrote beta V square only. Beta, God bless you, Suchit, for correction. Stay blessed, beta. Your all dreams, beta, comes true only. Literally, beta, I can this system, this life system, beta. I can say because of you, are totally energetic. Yes, I can tell, beta. Except you, no one talking anything here because there are watching four members. One is you. I don't know what's the three members. So very good, bacha. Because of you, I'm also. I got literally very much tired today, but still I got energized because of your support in live session. Literally, beta, I'm not feeling Suchi like I'm taking live class. No, not at all. Yeah, it's very. I can say because of this class went well because of you only, bacha. Because you are a good candidate. Now, bacha ji, this is what beta I can say. Case two. This is what, my dear? Case 2. What is case 2, bacha? No charge is fixed, but moving along the same line. Student, no, no charge is fixed, but moving along the same line, beta. Beta, it's very good thing, my dear, my kids. Okay, fine. So here, beta ji, we'll go through here. How can we do this kind of question, beta? Okay. Uh, Beta, there is condition here. Both charges can move along the same line. Beta, this is Q2. Beta, Q1 is not fixed, but beta, now I'm keeping students Q1 at rest. Q1 at rest, beta. Right. You can take, beta, this particle mass is M2, my dear. This particle mass, beta, you can take, my dear, it's M1. Right, beta? Okay. Students, here you can write again here. This is what. But initially, they are at large separation, my dear. Keep in your mind. Initially, beta ji, they are at large separations, my dear. Right? Okay. Now, beta, again, I'm projecting Q2, beta, with speed V naught, my dear. With speed V naught, my dear. Okay, fine. It I know, because what is it means here? Because this particle you availed kinetic energy. Due to this kinetic energy, my kids, this particle will approach, comes towards Q1, but not possible practically go towards finally Q1. Why? Because both are like charges. So Q1 will repel to Q2. And now which I can say Q2 will become also 0. Q2 will becomes also 0. No, sir, you can't say here 0. Why, bacha? Because this is also can move. So if they will come closer, so repulsive force will allow motion of this particle as well. So here both of particle will move with what bit I can say? Same velocity here. You can say bacha Q2 is also moving with V and beta G Q1 also moving with V. This is the conditions, my dear. And now, students, you can say this is what our minimum, which we wish to find. Closest distance approach. Now, beta, here I can see we have a variables more two variables. One is R minimum and one is V. So we wanted two equations. My kids, we wanted two equation here. So, beta, what you can apply first? Beta, you can apply. This is what, my dear, energy conservation. No. Sir, first we have to apply linear momentum conservation. First beta G, we have to apply LMC. First beta G, we have to apply LMC. Suchit beta, just confirm me once, my kids. Entire notes is visible, beta. Some part is, I can say, not visible for you. Entire beta notes visible for you, beta, or any part not visible for you. Okay, okay, Suchit beta. Okay, Suchit beta. I'll see beta in next class. 110% bacha party. LMC bacha. So here, kids, you can say this is what P initial is equals to beta G P final here. So what is P initial, bacha? You can say this is M2 into V naught. Both are moving here. I can see same velocity. So you can write, bacha G, M1 plus M2 into V. M1 plus M2 into V. So you can write, bacha party, V is equals to M2 into V naught upon beta G M1 plus M2 upon beta G M1 plus M2, right beta? Okay. Now students, I'm going to apply here, I can say energy conservation. Now students, I'm going to apply, this is energy conservation. Yes, beta. Energy conservation. So, bacha ji, you can say, sir, we have only conservative force. So, you can write here kinetic energy initial plus potential energy initial is equals to kinetic energy final plus potential energy final. Beta, initial potential energy here, zero, because particle at initially beta large separation. So, kinetic energy initial, bacha, you can say half m2 v naught squared. Bacha ji, half you can say m1 plus m2 into beta g v square plus k q1 q2 by bacha ji r minimum. Beta ji r minimum here. Now beta just you can say these two beta ji happy birthday. You can write Sujit beta m2 here v naught square which is equals to m1 plus m2 beta v square here. So you can write here m2 square v naught square upon students. You can say m1 plus m2 whole square plus beta. You can write twice of k q1 q2 by R minimum. Further, you can say, bacha, sir, this is and this is what? Cancel. This is and this is beta what you can say? Cancel here. So, just beta further you can solve. You will get my kids. That is what? R minimum from this equation. Right, bacha? So, I can say not less, little up. Do sir. Okay, 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 my dear. Is it visible, my kids? Is it visible, my kids? Okay, done, beta. Okay, okay, Sushil, I have another classmate here, 9 o'clock. Uh, beta, some kids from Bangalore. So now, beta, I'm going to stop your live session. Beta, I'll see you in the next class. Right, beta? I'll see you in the next class. Very good session, sir. Thank you, sir. God bless you, my kids. Sir, enough for today, sir. I'll eat dinner. Okay, okay, okay. Go, 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 beta. God bless you, Sushmita. God bless you, everyone.